here 4. Where there is x, we're going to replace with negative 2, which is going to be negative 2. And while here there is negative 1. So here, since we've now replaced what x, we've replaced with negative 2. Here we are having 4, we are having negative 2, we're having negative 1, and we're having positive 6. We are going to find the inverse now. So the first thing you do before you find the inverse, you are supposed to find the adjoint. When you talk about adjoint, we're talking about where those numbers that are in the major diagonal are going to swap. The one that is on top is going to go down, and the one that is down is going to go on top. This is where most of you make mistakes when you're writing your exam. So before you dive into the before you find the inverse, you're supposed to swap this. So meaning the 6 is supposed to go on top, the 4 down. Then these, since they're negatives, they're supposed to change their signs. If they're negative, they're going to change into positive, and if they're positive, they're going to change into negative. So here we are having negatives, meaning they're going to change into positive. So here we're going to say adjoint, which is abbreviated as this, adjoint B is equals to, we're going to open the brackets and do what we're supposed to do. So 6 is going to come here on top, okay? Then the 4 is going to come here down. The negative 1 is going to change into positive, and the negative 2 is going to change into positive 2. So take note here, because I know this is where some of you make mistakes when you are solving this question. Because this question is just mandatory. It is supposed to be there in your exam, whether paper 1 or paper 2. But as for now, we're dealing with paper 2. In paper 2, you are supposed to show all your working. Henceforth, it is very important. Okay. So after reaching this far, you found out the adjoint here. You are going to what? You are going to draft down the what? The formula for the inverse, which is inverse. You say inverse is equal to 1 over the determinant that you've gotten or you've been given. We're just going to abbreviate it as this times the what? This adjoint. Adjoint B. Okay, so this is the formula. After drafting the formula, now we are going to indicate the inverse. And this inverse is supposed to be indicated as like this. Since we're having B, it's going to be indicated as this. This one shows to say this is the inverse. Okay, so never forget this. As you write this, you're supposed to indicate this. You earn a mark for this, because it's showing to say you're finding what's the inverse. So here we're going to say is equals to the 1 over the determinant. Remember to say the determinant is not the negative 2 that we got after finding this. It is this 22 already been given. So here we're going to indicate 22, and we're going to multiply it with what will be in the bracket, which is what the adjoint. This, after finding the adjoint, where we're having 6, 2, 1, and 4. Luckily this time around, where most of you make mistakes is when you're given negatives. But as for now, you're not having any negative. Okay. So here it's time for us now to what to solve. So we're going to indicate B negative 1 is equals to 1 over 22. We open bracket, we say 6 times 1 over 22. We come, we say 1 over 20. Or even just like this, 1 over 22 times 2. We can say 1 times 1 over 22. And we can also say 1 over 22 times 4 is still the same thing, because it's still going to give you the same answer. So you say B negative 1 is equals to, okay? So here you're supposed to be careful. I'm just going to be solving it from here. You see here you're having this. You're going to say 6 times 1 over 22. 6 times 1 is going to give you 6 over 22. Is there any number that you can multiply into 22 and 6 without giving a remainder? Yes, there is a number, and that number is 2. So 2 into 6 it goes how many times? 3. And 2 into 22 it goes okay. Let's say in 20 2 goes how many times? It goes 10 times. Then in 22 it's going to add a 1, meaning it goes how many times? 11 times. So it's going to be 3 over 11. But when we look here, is there any number that can go in both or leaving a remainder? No. Henceforth, our answer is going to be just like this. You are not supposed to put in the fraction form where you divide and those sorts. So you're just going to indicate 3 over 11. Okay? You come to this, you say 1 over 22 times 2. Okay. So you all know to say 1 times 2 is going to be 2 over 22. We do the same. The number that can go is 2 itself. itself. So here it goes how many times 1, then here it goes how many times 11. So here, since this is now something like this, we cannot divide here. Because if we divide 11 into 1, it's just going to give us a fraction. Henceforth, we're going to get it the way it is, just like this. So we're going to say 1 over 11. Let's hope it's clear. Okay. So here we're just going to do direct. 1 times 1, which is 1 over here 1 times 22. Just put a place value. It's going to be 22. We come to this. We say 4 over 22. We've already done it directly. 1 times 4. So 4, we can use the same 2 as well. So here 2 goes, it goes 2 times, then here it goes 11 times. So meaning we cannot divide it further here. So we can just leave it just like this, 2 over 11. Okay. So now this is the what? This is the final answer you get. This is the inverse. Then you are done with it. Simple as that. So here, just to summarize the main points you are supposed to do. When finding the determinant, we say you are supposed to start. You are supposed to multiply those in the major diagonal, the product in the major diagonal, and the product in the minor diagonal. You are supposed to subtract them. So you are supposed to take note to say when you talk about major diagonal, we are talking about this. This is the major diagonal. Then this is the minor diagonal. Never start with multiplying the minor first, okay? Then when we come to index, one thing you're supposed to know, the important point is when you reach this point, you are supposed to do the adjoint. When you talk about the adjoint, you say those in the major diagonal are supposed to swap. Just like the way we swapped 4 came down when it was on top and 6 went on top. Then these, you are supposed to be strict on the what? On the signs. If these are negatives, they are going to turn into positive. If they were just positive like this, they would have turned into negative. Then you drag the what? The formula and you solve. So these are the important points you are supposed to do. But today I won't just spare you, I'll give you an exercise. So here we're going to try what? We're going to see if actually the knowledge that will be impacted in you about matrices, you are now able to answer questions that you are prepared to dive into the examination. Okay. So let me just give you a task that you are supposed to do. Okay.